From ContainerDays Hamburg, this video is proudly presented by Dux IT.
Hello, everyone. Today, we are going to talk about how to get started with eBPF. I'm Qasim.
I'm Mike.
We work as software engineer at Microsoft and maintain our project, Inspektor Gadget. It's a CNCF sandbox project, and it's the project we are going to talk about in this presentation. In terms of the agenda of the talk, we'll start by defining what eBPF is as a technology. Then we'll see the different challenges it has. And then we'll see how Inspektor Gadget addresses them. Then we'll take you through a couple of demos, post-processing workflows. Then we'll see the project roadmap. And then finally, we'll conclude our presentation. By the end of this presentation, you should have an idea on how to build a simple eBPF program, which we call a gadget, and take it all the way to Kubernetes. So what is eBPF? eBPF stands for Extended Berkeley Packet Filter. The name itself doesn't say much about what the technology offers. It essentially allows you to inspect or modify Linux kernel behavior without really changing the kernel code. It does that by running sandbox programs directly into the Linux kernel. These programs are event-driven, and they run when a kernel reaches a specific point or when an application reaches a certain point. These hook points could be system calls, function entry and exit, kernel trace points, or network events. Let's try to look at a very simple example. So we're just trying to count packets here. So whenever a packet is sent, we just increment a counter, and then eventually we will send that to user space for processing. So even a simple example like this gives you an idea of what you can do with eBPF.
So thanks. So why should you care about eBPF? Basically, because it's very powerful. It's operating at the kernel level, and you can get insights onto what is running on your systems without being dependent on any framework, language, stuff like that. And you can use it for several things. So for debugging, imagine you have a service running and that is doing DNS requests, and it doesn't get responses to that. You can use eBPF to look into your network interfaces and then see the packets in real time moving along and see where it's being dropped. Or imagine you're having an application that is just crashing randomly and you want to look into it. You can set up a couple of system call hooks and look into where, like, that it's being dropped or being crashed because of missing file permissions. But eBPF not only shines for debugging, it can also handle monitoring. So you can measure things like DNS latency. You can do CPU profiling with it. You can see which process is causing excessive I/O, for example, or you can just count your network traffic. And in terms of security, you can run eBPF programs to apply rules that whenever they hit trigger certain events. Like, for example, if a process is running a shell, execute something that it isn't supposed to run, if certain files are being accessed, or you can even filter network traffic at the kernel level before that hits your application. So with this great power of eBPF, there come certain challenges. For one, there's the packaging and orchestration. So if you're working on Kubernetes, you have to build the eBPF program, you have to deploy it, you have to somehow get it on Kubernetes, and you usually have a user space program that is receiving the data and takes action on it. And once you have that running, there's still it's the kernel's view on things, so it doesn't know about higher level abstractions like pods, namespaces, and such. So you still have to map basically what you're getting from eBPF to those things. And even if you get that right, then you still have to aggregate the data and export it to your observability pipelines or make it fit into your environments. in other ways. So this is why Inspektor Gadget was born. It basically takes your eBPF program, and you can add, yeah, it's optional, WASM module to it, and then combine that into an OCI image that you can push to registries and then consume from there, and then run. So Inspektor Gadget will do the orchestration for you. And Inspektor Gadget doesn't just show what the kernel is delivering, but it also knows about those concepts that I just talked about. Like it knows about nodes, pods, namespaces, and such. So it can enrich the data that is coming from eBPF with that data. And then you can either send it to your terminal if you want to just debug it, or you can export it to things like OpenTelemetry.
Okay, great. Thank you, Mike. So let's jump directly into some code and try to see what really is a gadget from that standpoint of view. So for that, I'll just switch to, OK. So hopefully you can see that. So in this demo, I would write a gadget to count packets being sent per container. So in order to do that, I want to start from an existing gadget. And that gadget is called packet counter. You can think of it similar to what I mentioned in the initial slide, but it contains a bit more than that. So let's quickly run this gadget and see what it does. So essentially, you see we have two fields. We have this COM here, and we have packets. And when it runs, it actually is able to get a packet count per process. And I want you to focus on NS lookup, because I'm actually running a workload which is generating these requests. So now let's try to stop it. And so I like this idea, and what my goal was to kind of make it container aware. So the first thing I would do is I try to get the source of this gadget. So in order to do that, I can use this init command, which actually takes the -- from flag, which is actually the OCI image with the gadget I just ran, and then the directory where it should copy it. In terms of like this init command, we're still trying to finalize the UX of it, so it'll be out there in the next release. So it was able to run it. You can ignore the warning. But this is where the actual stuff is. Like the gadget code was actually then put into this directly. I call it my gadget packet counter. And what I want to focus on in this part of the demo is just the eBPF part. And that's kind of the most fundamental part here. So I will close this. So this is like the BPF part. And it starts with some header files. Then it has a key, value, and a map, right? So the key actually is just the command you just saw before, like NSLOOKUP or something. And then the packets is just the counter. So you could see something like 40 or something for the NSLOOKUP. And both of them are actually put into this map. I call this stats here. So they're just, think of it like it's a key value pair, and you put like for a process, the counter there. So it's like just that idea. So and then this is something Inspektor Gadget framework provides. Like this is a gadget map iterator micro. And what it does is that it registers this eBPF map as a data source, and then it can iterate over it at regular intervals. If you could see the output for the previous run, you could see that it was being refreshed at regular intervals. So it's kind of that logic. And why I call it data source, and you can ignore it for this part of the demo, but in the next demo, we see why the idea of data source matters. Again, let's think in terms of like the hook points, right? So in this case, the hook point is like this UDP send message. So this will be triggered whenever a UDP message is sent. Then I use a eBPF helper that gets the current command, and then put that into the value. And then I have some logic to kind of look up them. If like for a specific process, we already have an entry in the map. If it's not there, we create it. Otherwise, we go forward and increment the count. right? So this is the basic program which just have no idea about containers and kind of is able to show what's happening on your machine. Let's switch back to the demo. I have a little test here. So before I build it locally, I have this command. You can see it's pretty similar to how you do things with Docker containers. But it's not your applications being packaged. It's actually the eBPF programs. So I'm just trying to run this gadget, but I'm specifying the -- container name flag. So I expect my gadget in the end to be container aware, right? So let's just run it and see what this is. Right? So you see that it has the runtime, that container information there. And what I want to do is that I want to go behind the scenes and see what made it possible. So let's get back there. So in order to make kind of this gadget container aware, what you would do is normally you need to include a header file, which is provided by the Inspektor Gadget framework. Need to be filter. And then what you need to do is that normally what I want to do is that now discard some data. Right? So I would do something like if gadget should discard current data. Right? So I showed you a test where I was actually running the gadget with the container name, and that takes that context and that context about the container name into when it discards the data here. So it's just, that's it. You need to kind of make your gadget container aware.
You need braces.
Yeah. They're there, right?
Function core.
What do you mean?
Discard data current and then...
Yeah. OK, cool. And like one other thing I want to mention is that we need this. I will put it in. So we need in the key the mount namespace ID. That's kind of the data we get from the kernel, which in the end will be replaced by the container name you saw. So think of it as a magic, but you need to have that in to be able to filter by containers. And then eventually what I would do is that I would just have that filled in by using one of the helpers Inspektor Gadget framework provides. Let's head back to the demo. And then just like you do it for Docker, I will run it. And it just builds the gadget. And it was able to build that fine. And I will go back and just run it again. I will close this terminal. And then let's run it again. So yeah, so this is like, again, I want to come back to this. I just show you how easily you can put in like the container context into your gadgets. And in the end, you get something like a container name out of the box, and then the process and the number of packets here. Oh. Yeah. So let's try to take things a bit like one step further. I talked about like we will go all the way to Kubernetes. So it's not about like doing it for a container at my machine. We want to really do it for Kubernetes. And for that, in Docker, normally you push the image, right? So we will do the same. We will push our gadget image to our registry. And in this case, it takes some time. I hope the network stays with me. But yeah, let it run in the background. But in general, like once it's pushed, then you are able to do things like you can use this kubectl gadget, which orchestrates the whole gadget across Kubernetes. And I'm able to use that to then like run the same packet counter, but within the Kubernetes. And cool thing about the whole thing is about the Inspektor Gadget framework is that you didn't have to make any changes to make it Kubernetes aware. So when you kind of put in the logic to make it container aware, Kubernetes logic comes with it. So let's just run it to kind of show the output here. So I want to just stop it, but you can see here, it's a bit truncated, but you have these Kubernetes fields in there. The Kubernetes node name, namespace, pod name, they're a bit truncated, but that's essentially what you get out of box with Inspektor Gadget. Now, to make it a bit more interesting, what I want to do is that I would do this demo with Inspektor Gadget MCP server. So we just build a gadget, and let's try to run it with Inspektor Gadget MCP server, right? So I would do it more like, hi, can you count packets in my cluster? So what it does is that it understands Inspektor Gadget, so it will like, hey, I want to check if it's deployed in the Kubernetes cluster. I run it, and then it goes behind A grade, it's deployed, and then it'll just run the packet counter we just built because we pushed it to a registry, and we can see that it specified like it want to run for all the namespaces, it want to run it for 10 seconds, and it is indeed able to get some data here. And then it comes up with a nice summary about like, it's like all the stuff I told before about like your gadget being Kubernetes aware. This is kind of one of the validation where MCP server comes back with like, hey, I saw that core DNS is sending 4 packets. Your DNS request generator, which is like a sample pod, is sending 3 packets. And then it gives you a really nice summary. So imagine you are able to take a catalog of gadgets, combine them, run it with these MCP servers, and get a lot of value out of it. So to summarize this packet counter gadget, what I showed was that like Inspektor Gadget provides like a container-like developer experience for eBPF developers. It makes it easy to package, share, and orchestrate eBPF programs. And it scales from local debugging, like you could do on your Linux box, to cluster-wide observability, where you were able to do it on a Kubernetes environment. Yeah.
Yeah, so let's take what we created now and take it even further. So we got a lot of metrics now, and we just want to export it to Prometheus. We're using OpenTelemetry for that. So let's see how we can do that. So let's go back to the demos. Close that one. That one. So just a little bit about how Inspektor Gadget works internally. We have a lot of operators, we call them operators, and one of them is doing the OTel metrics stuff. So in this case, we want to export it using the metrics using OTel metrics. So this operator is what we have to configure. And usually whenever you create a gadget, you create a gadget YAML file besides it that just has some additional data like a name description. You can put a lot of stuff in there. But you can also describe your data sources. That is what Qasim was talking earlier about. So when we exported the map, it became a data source. And in this file, we can now configure how operators should handle those data sources and the fields on them. So in our case, we now want to export things to Prometheus, so we have to add a couple of annotations. Like for the data source itself, the packet counter, we'll be adding this metrics.collect true annotation that will make the operator work and let it know that it should handle this data source. And on the fields themselves, we will be adding the metrics type. So for the pod name and the command, we actually want that to be keys for these metrics. So later on, they in Grafana become labels essentially. And for our packet counter, we want that to be of type counter. So if I'm now taking this, let's see. and replace this part. Save it, and then go back to the building step. So we rebuild this gadget with the new information. Great, that worked. We have to push it again. So our Kubernetes deployment will be able to pick it up. Just taking a second. Maybe let's close it and run it in the background. Oh, it did it. Great. And then we'll run the actual metrics collection. In this case, we'll provide some additional parameters to it. Since we're not interested in getting interactive feedback like we saw before on the command line interface, but we want to export data to OpenTelemetry, we want to keep that gadget running in the background. So we do this detach that will tell Inspektor Gadget to handle it as such. And then we also have to specify this explicit naming bundle. Like we want the OTel metrics operator to export our packet counter data source to an external like metrics package called packet counter as well. And if we run this one, it should give us an ID of the gadget. It did. Great. So then we have a Grafana Prometheus installed. There should be metrics coming in, hopefully any second now. Couple more seconds. Yeah, there they are. Great. So with just a couple of added lines, we were able to add an exporter to our gadget. And this is easily extendable. So whenever you add a field in eBPF, you can just export it just as easily. And currently, we support OTel metrics and OTel logs. So the case that we just saw was periodically pulling a map, getting the data from there and export it. But in eBPF, you can also create just events, send them to user space in real time, and that would be more a case for exporting it using OTel logs. Okay, let's quickly talk about post-processing. So eBPF is really powerful in what it can do, but it's still very limited in certain things. So, for example, you can only have a limited number of instructions in an eBPF program. That's limiting. And you also have a limited set of instructions that you can take. So there's no access to file systems in eBPF. There's no access to network in eBPF. You always have to go through user space to be able to do something, things like that. So in this case, as I said earlier, you can bundle a gadget with a user space part that is currently consisting of WASM binaries. So we provide support for Go and Rust that can be compiled into those WASM modules that you can just bundle with the gadgets. But there's always a performance trade-off, like mentioned. So whenever you're going through user space, that becomes more expensive as if you were handling it on the kernel. Okay, quickly on other front ends. So if you don't like going command line only, we have these two front ends in experimental stage. It's IG Desktop, that gives you a list of gadgets that you can browse through. You can use it for certain for many environments. It's like you can set up a list of environments that you work on, and it gives you a bit more details. Like you can zoom in stuff, you can scroll more. Like it's a more clicky experience. And if you're familiar with Headlamp, that's also an option. We provide a Headlamp plugin, which also lets you browse existing gadgets, and you can start them from there, and you can even embed them in Headlamp's views. So if you have the pod view on Headlamp, you can inject Inspektor Gadgets into those pages to see a real-time list of processes running on a pod or whatever you desire. let's quickly go over the roadmap as well. In terms of the framework, we're trying to get better in handling user stack symbolization. What that means is whenever you hook into user space, which is also possible using eBPF, this would allow us to better give you the function names that were called last, or wherever things took place, we are able to show you the stack for that. Then we're also introducing generic packet filtering, which then will lead to a new gadget that we call TCP dump, because most of folks are familiar with that. What that will give you is essentially a pod level possibility of capturing packets, then enriched with also Kubernetes awareness data. And we're also looking always into enhancing the OpenTelemetry support, because that framework just gives so many things. We're looking to add hotel tracing in the future. Let's see where that goes. And yeah, other than that, new gadgets will be coming also regarding GPU metrics, because everyone is doing AI, and that is based on GPUs. So we'll look into that as well.
Okay. So by now, probably you have an idea of how you can build an eBPF program or a gadget from an existing gadget and take it all the way to Kubernetes or export metrics out of it. So we're trying to build an ecosystem around gadgets. So we have this set of official gadgets, like a catalog of gadgets that solve some problem for you, like trace DNS, trace TCP, and around different networking, and also other information to help you debug things. So you can help us by bringing in your use case that we can address with this official catalog of gadgets. And then you can also write your own gadgets and then share it with everyone in this community gadgets we call, and then you basically can use Artifact Hub to kind of make it discoverable for everyone else. Yeah, so you can find us in Kubernetes Slack under Inspektor Gadget channel. And we're also on Discord. So you can learn more about the project from our website, or you can head to GitHub, and you can find all the information about the project there. And that's it. Thank you so much.
Thank you.
Did you choose C for Inspektor Gadget because of you like know it, or because is there another option to interact with the eBPF world with a small hint? What about Rust?
So Inspektor Gadget itself is built on Go. So we're using Go for all the framework. What we support currently for building is just C. So if you like to get eBPF from other sources, compiled from other languages, you can also inject that into the gadgets, I guess. But we don't support a way for that now. But if you're interested in that, just give us a note, and we'll look into that.
Oh, just a hint. Please use dark slides. Okay.
Okay, next time. Yeah. You want to take that?
What about eBPF for Windows?
I think right now we don't have that on the project map to add support for the Windows. But we're, again, like Mike said, open to kind of discussion on the roadmap and trying to put that in there.
How does the Inspektor Gadget eBPF metrics collection compares with the OpenTelemetry auto instrumentation?
You want to take that? I personally feel like with Inspektor Gadget, we're trying to build a framework where you pick and choose your metrics. Like, you can have a gadget that gives you everything out of the box, but you sometimes want to control what you get out of it. Like, you need to control the cardinality, because in the end, you pay for every storage, everything in the storage you have. So we're trying to have something a bit more generic. So you kind of have things done in an automated way, but you can fall back to a more controlled way of doing things as well.
Okay. Let me go back to the questions. So the first one you answered right. Are you planning to support AYA eBPF programs written in Rust?
We're not the experts on Rust, I think.
Yeah.
But well, we might look into that. So,
Yeah.
or at least tell our colleagues that are doing the Rust part.
It seems to be a big deal. What languages are supported with eBPF programs?
It's the same. Like if you can build it, like if you can build the eBPF objects that contain also BTF information, because we heavily rely on that, then you can bundle it in a gadget with a bit of hacking.
Yeah, but I think it's more about like these helpers that I was using when I was changing the gadget or showing you. They are in C right now, so it's more like all the demos and everything is also in C right now, or this pseudo C we have for eBPF.
Thank you. And the last question is from Victor. Can you expand on why are you compiling to WebAssembly and what are the trade-offs? Thanks in advance.
Yeah, it's like we showed you in the demo when we did like IG build. So by default, it's try to look for certain directories. So it's, for example, for Go, if you have a Go file in there, it'll try to compile it. So it's built within to the IG, like the build chain, so you don't have to do anything special to compile the WASM modules. So there are a few gadgets there that already have it, so you can see how that's working. But in terms of the build process is kind of similar to what we showed in the demos. And in terms of the trade-offs, I mean, it's like Mike said, it has a performance penalty because normally you do things within the kernel, and in WASM you are doing everything in the user space. We had issues with that when we were using the older versions of Go or the Go Tiny.
TinyGo, yeah.
TinyGo for the building the WASM modules, but now that the Go support for WASM is out, we switched to that. It gave us pretty decent performance numbers, but still, if you care a lot about the performance, we have all these benchmark ways to do things, so you can also look into that. But in general, if you could do things more in eBPF, that's like kind of more performant.
Yeah, and in general, why WebAssembly? It's because it's also sandboxed, so we have a little bit of control what can actually happen there. If you want to like go crazy on eBPF with Inspektor Gadget, you also can use the Go API that we provide. Then you can just do whatever you want in user space, and that will be performant as it can be. Yeah.
Great session, thanks. I definitely agree. If you have more questions to Qasim and Michael, I have to correct myself. In the morning I said there will be a live band tomorrow. As you might be heard already, they will play tonight. It was a sound check before I asked them to stop. Yeah, maybe we will meet there. Thank you. Thank you.
Okay, thanks.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.